Hello friends, in this session we are going to see some new classes related to input output in detail, Java IO package. Okay, so new topics, new classes we will see now. We will start with buffered output stream. Buffered output stream is similar to any output stream with the exception of an added flush method that is used to ensure that the data buffers are physically returned to the actual output device. Okay, so similar to output stream class we have seen with an added exception, added flush method that is used to ensure the data buffers are physically returned to actual output device. Okay, instead of unlike the other output stream classes, flush method is written physically. Okay, actually it is written on actual output device. And since the point of a buffered output stream is to improve performance by reducing number of times the system actually writes data, you may need to call flush to cause any data that is in the buffer to be immediately written. Okay, so it will reduce number of times the system actually writes the data. So you will call flush so that data is immediately written. Okay, so for immediate result, you will call the flush method. Unlike buffered input, buffering output does not provide additional functionality. Okay, buffers for output in Java are there to increase the performance. So there are two available constructors: buffered output stream object, and buffered output stream object and buffer size. Okay, the first is creating buffered stream using the default buffer size. Okay, generally this is 32 bits, and second is size of the buffer is passed in buffer size. Next is pushback input stream. One of the novel uses of buffering is the implementation of pushback. So what is pushback we will see now. It is used on an input stream to allow a byte to be read and then written. That is pushback. Read and then written to the stream. The pushback input stream implements this idea. It provides a mechanism to peek at what is coming from an input stream without disrupting it. Okay, what does that mean? You have to, that input stream allows a byte to be read and then written, pushed back to the stream object. Okay, so this class specially is made up for that purpose. It provides a mechanism to peek at what is coming from input stream without disrupting it. Two constructors are pushback input stream object, and number of bytes. The first one creates object that allows one byte to be returned to the input stream pushed back. The second form creates a stream that has pushback buffer that is number of bytes long. Okay. So first we'll have the standard size 1 byte at a time, and second how many we will specify how many bytes we are pushing back at a time. Okay, so that will be depending upon you, or we as a programmer we will specify the number of bytes and those bytes will be pushed back. Okay, this allows multiple bytes to be returned to the input stream if we are specifying more than 1 byte, so that it will speed up the process. We will see the new methods with the pushback stream: void unread integer character, void unread byte buffer array, void unread byte buffer integer offset integer number of characters. Okay, the first form pushes back the low order byte of ch. This will be next byte written by a subsequent call to read. The second form returns the bytes in buffer. First is low order byte of character that will be pushed back. Second is next byte returned by subsequent call to read. Okay, then second form returns the bytes in buffer. Whatever bytes are there, those will be pushed back to the buffer array. And third form, pushback, number of character byte beginning at offset from buffer. Okay, so you will specify particular index. From that index, how many number of character bytes you have to read and push back. Those will be specified. Okay. IO exception will be thrown if there is an attempt to return a byte when pushback buffer is full. Okay, so that is also having a limit. Here is an example. We will see how a programming language parser might use a pushback input stream and unread method to deal with the difference between is equal to for comparison and is equal to for assignment. Okay, so first string is if a is equal to 4, a is equal to 0. Byte buffer, first of all, we will get bytes using the get bytes method. Second, byte array input stream, we will take the byte array input stream, that byte array we will specify over here. And then that byte array input stream object we will specify in the bracket of pushback in our input stream. Okay, so character one by one we will read. Unless end of the string is encountered, we will read in the while loop. Switch character case is equal to. If C is equal to F dot read is equal to is equal to. Okay, so it is equal to. Okay, so equal to sign is why we are using the equal to sign. Whatever is written in the right side of the is equal to operator will be assigned as a value to the left side of the operator. Okay, so if it is like a is equal to 3 semicolon, so 3 will be assigned to the a. So what we are checking over here, if the sign is equal to, then we will print it as equal to, else we will print as arrow. Okay, left arrow, then f dot unread 6. Okay, next default character C we will cast and display on the console, and notice that is equal to, here is the output, is equal to was replaced by equal to, and is equal to was replaced by arrow. If a equal to 4, a less than 0, a arrow 0. Okay, pushback input stream has the side effect of invalidating the mark or reset. To use of the input string is to create it. Okay, use mark supported to check any string on which you are going to use mark or reset. Okay, so what is the inadvantage or side effect? It has a side effect of invalidating mark or reset methods of the input string used to create string. Use mark supported to check any string on which you are going to use mark or reset. So we will check if it is true or false. Mark supported, so that you will understand on which you are going to mark or reset. Sequence input stream. Okay, sequence input stream classes allow you to concatenate multiple input streams. So it is in sequence one after the another, and like one after another, and it will concatenate multiple input streams together. The construction of input stream is different from any other input stream. Sequence input stream constructor uses either a pair of input stream or an enumeration of input streams as this argument. Okay, why pair or enumeration? The first is using pair, like sequence input stream first, input stream second, because it is a sequence input stream. So it will need at least one, more than one, that is at least two to concatenate. At least two input stream it will require as the object. Okay, and second is enumeration. Means what? Enumeration is iteration over the input stream object. Okay, so you will iterate through the input stream, whatever are there, whatever number of are there, and you will try to concatenate or combine them. Okay, the class fulfills read request from the first input stream until it runs out, and then switches over to the second one. Okay, So first input stream object, it will take first for the first constructor. Until it runs out, it will read the request until the end of input stream object is encountered and then switches over to the second one. And in case of enumeration, it will continue like a for loop to enumerate through all of the input streams until end of the last one is encountered. Okay, so now we will see the sequence input stream to output the contents of two files. Input stream enumerator implements enumeration file input stream. Okay, so you have to use this line implements enumeration. Okay, then private enumeration we are creating for string input stream enumerator your constructor vector string of files. These dot files dot elements. Okay, so why we are going this vector string of files, we will add as many files as needed at runtime. First of all, so that it is vector. Second, there are file names given as a group of files, and those elements will be taken one by one, and those all elements, these dot files will be put into the enumeration. Okay, so vector files elements are put into these dot files, that is enumeration files. Okay, then has more elements is true, then it will return file has more elements, true or false. Then next element, return new file input stream files dot next element dot to string. Okay, so next element, that is next file, and if there is next file is not available in the vector to enumerate, it will return the null. The sequence input stream demo. In main function, what we are doing, we are creating new vector, and in that we can add as many files as we need. Autoexecute.bat config.system. These are the two files we have added in this vector. Okay, one by one. Then input stream enumerator object, we will pass this vector as a constructor. Okay, this is the constructor, so that it will be initialized to two files. Okay, then we will try with more, has more elements, and next element input stream new sequence input stream E. Okay, while C is equal to input read minus not equal to -1, we are printing character casting and input dot close. This example creates a vector and that adds two file names to it. It passes the vector of names to the input stream enumerator class, which is designed to provide a wrapper on the vector where the elements written are not the file names but rather open file input stream on those names. Okay, sequence input stream opens each file in turn and its example prints contents of two files. Okay, next print stream. The print stream class provides all of the output capabilities we have been using from the system file handle since the beginning of the course. It makes print stream one of the Java's most often used classes. Okay, so what is print stream? All of the output capabilities to print the output on the console like system.out since the beginning of the course. Then it implements appendable, closable, and flushable interfaces. So these are the constructors: print stream, output stream, print stream, output stream, boolean flush on new line, print stream, output stream, then boolean flush on new line, string character set. Okay, first is having only one object, output stream. Second is having one object, output stream, boolean flush on new line, true or false. If it is true, it will flush on new line each and every time the console is outputted, and if it is false, it will not go to the new line. Then third one is print stream, output stream, boolean flush on new line, true or false, and string character set. Here output stream specifies an open output stream that will receive the output. Whether the output buffer is automatically flushed every time a new line character or a byte of array is written or when println is called. If it is true, it will go to new line, otherwise not. Okay. If it is true, flushing automatically takes place. If it is false, flushing is not automatic. First constructor by default does not automatically flush. You have to flush it. You can specify character encoding by passing its name in character set. The next set of constructor give you an easy way to construct a print stream that writes its output to a file. Okay, so we are printing output to a file over here. Print stream file output stream, file output file throws file not found exception. Print stream file output file string character set throws file not found exception, unsupported encoding exception. Print stream string output file name throws file not found exception. Print string, string output file name, string character set, source file not found exception, unsupported encoding exception. Okay. So these are 4 type of constructor of print string. These allow print string to be created from a file object or by specifying the name of the file. And in all cases, in either case, the file is automatically created. Okay. First is output file, then character set, then output file name, and output file name string character set. Okay. Any pre-existing file by the same name is destroyed or overwritten. Okay. Once created, the print stream object directs all output to the specified file. You can specify a character encoding by passing its name in character set. Print stream. So what is the character set? You can specify a character encoding. Which type of encoding you want to specify to write to a file particularly. Okay, so that will be specified by character set. Next, print string supports the print and println methods for all types including object. If an argument is not a primitive type, the print string methods will call the object to string method and then display the result. Okay. The printf method was added to print string. Okay. Print and println method we have already seen. Okay, if an argument is not primitive type, print string method we call the object to string method and then display the result. The printf method was added by print string by Java 5. Okay. So previously it was not there. It was only in C++ programming language. It allows you to specify the precise format. The precision specifier, format specifier we have already seen in the previous chapter. The printf method uses the formatter class. The previous chapter we have seen to format data. It then writes this data to the invoking string. Okay. Although formatting can be done manually by using formatter, printf streamline the process. Okay. Because printf is the easiest way to do this, and we have already understood it in C and C++ programming languages. It also parallels the C++ printf function, which makes it easy to convert existing C++ code into Java. Okay, so you can directly take the C++ printf function and you can convert it into existing C++ code that convert that into particularly Java programming file. Printf is a much welcome addition to the Java API because it greatly simplifies the output of formatted data to the console. Okay, so printf forms are print string printf, format string, object variable name var, then print string printf local, which type of local you are residing in or you want to specify over here, string format string like %f, %d, %c, etc., and var. The first version write var to standard output in the format specified by format string using the default local. Okay, default local is the current local in which you are residing in. The second let me specify a local. Okay, as to specify the local object, depending upon that, it will write the output to the standard output. Okay, that is console. Both return the invoking print string object. Printf works in a manner similar to the format method specified by formatter. Format string consists of 2 types of items. First type is composed of characters that are simply copied to the output buffer. The second are format specifiers that define the way the subsequent arguments specified by varas are displayed. Okay, if it is %f, %d, %c, depending upon that, and we have already seen different types of specifiers. Using those specifiers, we can write the data. For complete information, including a description, we will see. Please see the formatter class we have explained in the previous chapter. Because system out is a print string, you can call printf on the system out. The printf can be used in place of println, where writing to console whenever formatting output is desired. Okay, so you can simply replace the println with the printf as and when needed. But it is after Java 5, not before that. Okay, if you are using the version that is of Java before JDK 5, you will not get this facility. For example, following program uses printf to output numeric value to various formats. Okay, here are some numeric values in different formats. %d, %d, %+d, %05d, etc. etc. Default floating point format, floating point with commas. Okay, so for default it is %f, %f, then negative floating point %f/n, negative value, %, f, opening parenthesis f, negative floating point option, then line of positive and negative values, %, 0.2f, %, 2.2f, etc. etc. Okay. Here are some numeric values in different formats. Integer formats are 3, 3, +3, 0, 0, 0, 3. Then default format, floating point format are this one, floating point with commas here, negative floating point default, and negative floating point with option. Okay, so you can take a screenshot of this program if you want to try it at home. You can try it, or we are going to discuss in practical part also. Okay. So these are format specifier and there are different output types we have seen or understood in the previous chapter. So depending upon that, it will produce the output. Print stream also defines the format method. The format method, first format is format string object variables, and it works exactly like printf. Okay. Next is data output stream and data input stream. Enable you to write and read primitive data to or from a stream. Okay. They implement data output and data input interfaces respectively. Okay. These interfaces define methods that convert the primitive values to or from a sequence of bytes. So these are dependent upon the primitive data, and that defines methods that convert the primitive value to or from a sequence of bytes. So convert them from byte to primitive data and primitive data to byte. These streams makes it easy to store binary data such as integer or floating point values in a byte. So primitive data can be written easily or read easily to or from byte respectively. Data output stream extends filter output stream, which extend output stream. Okay. Data output stream constructor is output stream object. Here output stream specifies the output stream to which data can be written. Data output stream supports all of the methods defined by its superclass. However, it is the methods defined by the data output interface which it implements that make it interesting. Okay. All of the superclass methods can be used by the data output stream, but in the data output stream interfaces, some methods are there. Those make it interesting class, and these methods are those methods that convert the values of primitive type into byte sequence and then writes to the underlying stream. Okay, first of all, it will take the primitive type into byte and then convert that into byte sequence and then write to the underlying stream. So sampling of these methods is final void write double value throws IO exception, final void write boolean value throws IO exception, final void write integer throws IO exception. Okay, value is the value returned to the stream. Okay, what it does, it will take a primitive type, it will convert that into byte sequence and then write to the underlying stream. So three methods are there: write double, write boolean, and write int, and value is the value returned to the stream. Is the complement data input stream is a complement of data output stream. It extends filter input stream, which extends input stream and it implements a data input interface. And here is its only constructor: data input stream and input stream object. Okay. Here input stream specifies the input stream from which data will be read. Okay, so it will specify the object of input stream and from which, for example, from which for each external device data will be read. like data output stream, data input stream, all of the support all of the methods of the superclass, but it is the method defined by data input interface that make it unique. And this method read a sequence of byte and convert them into values of primitive type. So first of all, it will take a input stream object, it will read sequence of bytes and then convert them into primitive type. Okay, it will read double, convert it into double. It will read boolean, convert it into boolean. It will read int, convert it into int. Okay. So now we will see the program with both data output and input stream. File output stream, new file input output stream, test.dat file we are creating. Data output stream, new data output stream with out as a parameter, out.write double 98.6, out.write in 1000, out.write boolean true, out.close. Okay. A file input stream fe, new file input stream test.dat, data input stream in is equal to new data input stream fin. Okay. So first one output stream test is done. Now file input stream we are starting to read from the test.dat. We have already written 98.6, 1000 and true onto this file test.dat. Now we will read this file. We will create the object of data input stream and pass the file input stream as a parameter, and then read double, convert it into read double, read in, convert it into integer, read boolean, convert it into bit. Okay. So values are displayed and then close. There are the values 98.6, 1000 and 2. Okay, so very simple program, nothing to worry about. Next is random access file. Encapsulates a random access file. It is not derived from input stream or output stream. It implements the interfaces data input and data output. Two interfaces it implements which define the basic input output method. And this file is randomly accessed. It also implements the closable interface. So three interfaces it implements: data input, data output, and closable. Is special because it supports positioning request. That is, you can position the file pointer within the file. Two constructors: random access file, file object, string access, throws file not found exception. Random access file, file object, string access, throws file not found exception. Random access file, string file name, string access, throws file not found exception. Okay, so these are two constructors by random access files. Okay. In the first form, file object specifies the name of the file to open as a file object. The second form, name of the file is passed as a file name. First is having file object, second is having file name. Okay. Okay. So we will continue this session in the next video because of electricity problem, Wi-Fi has been disconnected. So my voice may be not clear if I continue with the same video. Okay. So I will take a break over here. I will terminate this video and I will continue this with the new session.